For two-dimensional constellations, the optimal design, which is based on the sphere packing technique, leads to hexagonal constellations. In this video, we will see that in some systems, instead of using hexagonal constellations, some other constellations are used for practical reasons. The design of two-dimensional constellations by means of the sphere packing technique leads to hexagonal constellations. Constellations like this one. These are optimal in the sense that they have the best possible trade-off between probability of error and mean energy per symbol. The best trade-off between energy per symbol and distance between symbols, the minimum distance between symbols. The constellations are hexagonal, and in general, the decision regions are hexagonal. For instance, we can see that this hexagonal configuration for the same minimum distance is much more compact than a rectangular configuration, and therefore the mean energy per symbol is much lower than the mean energy per symbol that we have with the rectangular arrangement. However, because of practical considerations such as the simplicity to implement the transmitter or to implement the receiver to check if an observation is in a given decision region, or maybe to have a constant energy per symbol, or to have a good peak power to average power ratio. For several possible practical considerations, in some cases, some other constellations are used. QAM constellations, PSK constellations, unipolar constellations, orthogonal constellations. Probably the most common two-dimensional constellations are QAM and PSK, and because of this, we will see this kind of constellations now. The symbols in a QAM constellations are arranged in a square grid. The main advantage is that the implementation of both the transmitter and the receiver is relatively simple, because in this kind of constellations we can see that basically what we have is two independent one-dimensional constellation per dimension, and this makes possible to implement independently the transmitter and the receiver for each component, for each dimension. In PSK constellations, the symbols are arranged in a circle. Are points in a circle, all of them have the same modulus. This means that all the symbols have the same energy. If we prefer to transmit always a constant energy, this is a good choice for the constellation. A PSK constellation, points in a circle in the plot of the corresponding constellation. Summarizing, although hexagonal constellations are optimal in the sense that the best trade-off between probability of error and energy, in many practical communication systems, the most common constellations are QAM constellations and PSK constellations. Symbols in a square grid for QAM constellations, where the independence between the two components make easy the implementation of both the transmitter and the receiver, and symbols in a circle where all the symbols have the same energy.